Okay, so there is a basic procedure we have to follow when constructing a frequency distribution. And it's pretty simple actually, but very useful. And let's not forget why we're doing this. If you have large amount of data, you would like to have a good summary of the data. You would like to break that data down into different intervals so you could have a proper summary of whatever the data is. So let's say you have used your holding period return formula and you came up with 12 annual returns. And these are percentages, by the way. So you have 7.16 minus 4.57 up to 4.68% of returns. Now the first step to construct a frequency distribution is to sort the data. So this is what the data looks like sorted. We have minus 4.57, that is our lowest because we are sorting it in the ascending format. So this is our lowest return, minus 4.57, and our highest return would be 11.43. Now, to break the data down into intervals, you need to know what the range of the data is. And by range, I mean the difference between your maximum value and your minimum value. So you want to find out what is the difference between the minimum and maximum value. Our maximum value is 11.43, then minus 4.57, right? So there will be a 16% difference between my minimum value and my maximum value, which is my range, right? Now this is what I want to break down into intervals. That's 16%. So I have to decide, first of all, how many intervals do I want to have? And that's up to me. I could decide to have 4 intervals, 8, or 10 intervals. And obviously, the more intervals I have, the more details I can include, which is not always a good thing because if you have too many details, then you're not really summarizing. And if you pick a small number of intervals, then you have summarized too much and you might lose some, valuable information in there. So the number of intervals, let's call it K, is really depends on what you are trying to accomplish. Do you want to include more details or not? So the number of intervals that I will have will dictate what will be the width of my intervals. So the width of my intervals will be the range divided by k, and k is the number of intervals that I would like to have. Let's say I want to have, for the sake of simplicity, I want to have 4 intervals, right? So my range is 16 divided by 4. That means the width of my intervals are going to be 4%. Now, if I decided to have, 8 intervals, then the width of my intervals would be 2%, right? 16 divided by 8. So now, to create my intervals, all I have to do is to take this number, the width of my intervals, and start adding it to my, lowest value. In this case, minus 4.57. So I add this 4% to this number and then come up with a number, minus 0.57. And then again, take that number, again add 4, come up with another number, and continue this until I get to my last observation. Then I will stop. Now I have 4 intervals. The first interval is minus 4.57 up to minus 0.57 and then goes on until the last interval is 7.4 up to 11.43. So I have 4 intervals and each interval has a width of 4%. Now that I have my intervals and the endpoints of my intervals are clear, all I have to do is to count how many observations are there within each interval. For example, the first interval, minus 4.57 up to minus 0.57, I got to count how many are there in this interval. So that's 1, that's another one, that's another one, this one is bigger than this, so that's it. I have 3 observations in this interval, and I will do the same for the other intervals. And this is what it looks like. So after my count is complete, I got three observations in the first interval, 4 in the next, and this is how it goes on. But one thing to keep in mind is that when we are talking about intervals, this is the signs that we use to identify that what we mean is that this is a greater than equal sign. That means we are including this observation also, but up to this point, we're not including this one, right? So, and in some cases they write, they show it with like a bracket here to show that this one is included, and like a parenthesis to show that this one is not included. So it's very important to keep that in mind, because we don't want to have observations overlapping in different intervals. So, observations should be uniquely placed in each interval. So in my first interval, for example, we do not have minus 0.57 in our observations, but even if we had it, we would not include it here. We would include it in this one, right? So that will be the case for all the intervals until we get to our last interval. Then we should include both observations. So the last interval we would include both, but the other intervals we would just include up to the upper limits. All right, so let's see what it looks like in the table form. And one thing that you'll notice in the table that, here we don't need to include this greater than equal sign or brackets. Everybody assumes what you mean, so you don't need to include it. And also, the actual number of observations that are within each interval, it is called absolute frequency. And using the absolute frequency column, I can quickly see which interval has the most number of observations, which one has the least number of observations. In our case, the last interval has only one observation, and as for the most observations, we have two intervals, interval number 2 and 3. And if we add up all the observations, what are we going to get? We're going to get the total number of observations, which is going to be 12. Okay, now let's talk about the next column, relative frequency. Relative frequency it's just telling us what percentage of observations are in each interval. So that will be like, in this case, the first interval, that will be 3 divided by 12. That will be 25% of the observations. And when I say percent, well, it is sometimes better to express the relative frequency in terms of percentage. That will make more sense. So that's telling us 25% of the observations are in the first interval. And the next interval, that will be 0.33, and the 3 goes on. So that will be 33.33% of the observations are in here. And the same thing goes for the next interval. And the last interval would be 8.33% of the observations are in here. And again, if we add up all the the relative frequencies here, what are we going to get? We're going to get 1, right? And if it's expressed in the percentage form, that will be 100% of the observations, right? Now, when we are talking about cumulative frequency, well, the name itself is clear, I think. We are accumulating, right? We are adding up. So cumulative frequency, we are adding up the absolute frequencies. In the first case, we have nothing to add. It's just 3 itself. Then the next interval, we have 3 plus 4. That will be 7. Then plus 7 plus 4, that will be 11. And the last one should become 12, right? So that's telling me that how many observations are there up to the upper limits of each interval, right? So that will be 7 observations are there in, from minus 4.57 up to 3.43, right? 11 observations are from minus 4.57 up to 7.43, right? And 12 observations from here until the last observations, obviously. And cumulative relative frequency, I'm pretty sure you can guess what that is. If you were talking about relative frequency, that was the fraction of absolute frequencies. Cumulative relative frequency is going to be the fraction of cumulative frequencies. So that will be The percentage of the cumulative frequencies, that means the first one, well, it's the same thing. That is, again, better to express in the percentage form. That will be 25%. This one would be 58.33% of it, and then 91.66 and 1, which again expressed at the percentage form, that will be 100% of all the observations, right? So you can find cumulative relative frequency the same way as you got relative frequency, but using this column, that will be 3 divided by 12, in this case 7 divided by 12, or you can just add up the relative frequencies. You know, the 0.5833 is the result of adding 0.25 plus 0.33 something, right? So the same thing, we could just add these up, or we could just find the percentage, just like we did for the relative frequency. And that is all for the frequency distribution. We have all the columns, and when you're presenting data, you should include all the columns so that anybody reading your research can understand exactly what you're saying and can find out whatever they're looking for. For example, using this cumulative relative frequency, I can easily see that more than 50% of the data is in the first two intervals, right? So I can clearly see that, and I can use this and say, and we are using a very limited number of data and intervals, so it's not going to make a lot of sense here. But if you have a lot of data, that will be very useful things to know where how many intervals contain 50% of the observations, stuff like that. That will be very useful. So this is how it is. And one last point to make it all complete the frequency distribution concept is that here we are using minus 4.57 because that was our first observations. But you don't have to use the exact number. You can round it actually, because working with the decimals like that might be sometimes difficult. You could round it up. And when we are rounding, we normally round up rather than down. So for example, instead of 11.43, you could have used 12. And instead of minus 4.57, you could have talked about minus 5. So, right? So this would be the range of your data, and the number might change if you change these numbers, right? And you might not get the same range, but that doesn't matter. So you should round up rather than down, so you could include whatever the observations that you have. When you round up to minus 5 instead of this number, you would still include this number anyway. And 12 instead of 11.43, still this one will be in there somewhere. So that will be fine. And that way it might be easier to work with than working with decimals. So you're free to do that. It's fine. And the last thing would be the good thing about frequency distribution is that remember those measurement of scales we were talking about, right? It works with all of them. So you can use interval analysis for any kind of scales. So that's it. But still, if it hasn't made sense to you that much yet, it's all right. We are going to do many examples, and when we are having, we're working with a lot of data, and it will make much more sense to you once we have done few examples. So don't worry, just wait for a while. It will make a lot more sense to you later. But before we do that, before we do few examples, let's see whatever we have come up with in a graphical way. Let's have a graphical representation of our table. Well, because everything is better with a picture, right?